Welcome to the Evolution Show. I'm Johan Landgren. I hope you're great. If you're new to the Evolution Show, I'm a writer and full-time investor in sustainable tech, and I've written and researched about different smart energy solutions for about 10 years. On the Evolution Show, I share my experience, including the energy house I'm currently planning, and I invite inspiring guests to talk about renewable energy, electric transports, and artificial intelligence. I hope people find the content useful and inspirational. The previous episode was the first time I talked about my energy house project, where I took delivery of an 8,000-liter rainwater tank. Check that out if you're interested. Today I'm back in the Evolution Show studio, and I'm joined by the leader behind AlfaWall Oceanbird, a joint venture developing the world's largest sailing ship for freight. The 200-meter long and 40-meter wide Oceanbird sailing vessel is propelled by a super cool wing sail technology that may transform the whole shipping industry, and that is to be ready already in 2026. I hope you liked the episode, and if you do, don't forget, give it a thumbs up and consider subscribing. As always, stay ahead of the curve and stay electric. This is the Evolution Show. Welcome to the Evolution Show, Niclas Dahl.
Thank you.
You're Managing Director of a very exciting project or joint venture, AlfaWall Oceanbird. And you are developing the world's largest sailing ship for freight. It's actually 200 meters long, 40 meters wide sailing vessel, and it will be able to carry up to 7,000 cars. Really amazing. And you're using 4 foldable, 40 meter high and 15 meter wide wing sails. And the Oceanbird vessel is to be ready for the market already in 2026, which is pretty soon actually. Can you briefly tell us about this really exciting vessel, and how far are you in the process of making a full-size sailing vessel called the Oceanbird?
Yes, we are working on it quite a lot right now. I mean, it's very intense, as you say. It's quite narrow in time, 2026, so a lot of things has to be done. There are some changes being done on it, so actually it's 6 wing sails that we have on this one. And just to also make it clear, the Oceanbird is actually a company who makes the wing sails. So it started up as Oceanbird was a research project 3 years ago, and that was the complete concept. And then during last year, it was then decided that we create the company around just making the wing sails, because that is a quite difficult task to do. So we are focusing on that, and then of course Wallenius Marine and Wallenius Wilhelmsen are focusing on the ship to do that. So it's ongoing right now.
And we're going to talk much more about all the technical details, but first a little bit about you. It would be interesting to hear your background and how did you end up in this really exciting project?
Yeah, I come from Alfa Laval side, so it's a joint venture between Alfa Laval and Wallenius. I've been working there 24 years in the marine industry, working with sustainable shipping quite a lot. So I started up Pure Ballast, that was one of the products. It's also a joint venture between Wallenius and Alfa Laval, and then worked more with traditional fuels and also new types of fuel like methanol or ammonia and these parts. So when this came up as a question that you can work with this with the wing sail, it was too exciting to really say no to it. So in December last year, we started up the company. It was formed. So we were 4 persons then moving into the company, me as a managing director. Today we are 11 employees and we are continuing developing this. So it's a really, really exciting journey.
Yeah. And I mean, for those unfamiliar with this Oceanbird vessel, it's pretty mind-blowing for me. I mean, 2 years ago, I had a colleague of yours at the Evolution Show, Per Tunnell, and he talked about saving up to 90% of the fuel from oceanic shipping. using this Oceanbird wing sails, which and also with wind-friendly routing, which I know that you will talk about. It's also and all the also introducing aerodynamic design of the vessel. So my question, of course, and I think many people wonder: you still think you can save up to 90% of the fuel using this technology?
When you look at the whole concept, I'm convinced that you can save up to 90%. But it's more than just the wing sail, as you say. I mean, it comes into how willing are you to change your route depending on wind. It also goes with what speed are you looking into for the vessel. On this, it's the dimension on 9 knots and so on. A lot of factors, as you're also mentioning, regarding the hull optimization. So it's not only the wing sails that will get down to the 90% savings, but it's a big portion of that. But for the whole concept in the ship, it's really amazing to see that we can do this much.
Yeah, and for people who don't know, you also are able, you're talking about rebuilding the current fleet or other ships that already operate today using the Oceanbird wings. So could you tell us about that?
Yeah, I mean, Oceanbird, our vision is to really revolutionize the shipping industry. And if you're going to do a big change, I mean, on sustainability, it's not building 5 or 6 of these ships. We're talking about, I mean, the existing fleet. So if you're going to do something really big, you also need to address the existing market. So this is something that we're working on. Of course, it comes natural for us to work with the car carriers right now. But then, of course, later on, we will also have for bulk vessels and for tanker vessels. Then I'm sure that we will come into container vessels and a lot of other types later on. But every ship type have their own challenges. So we need to look at really and do it in a smart way and a good way for each ship type.
And do you have interest already from current shippers to interest in rebuilding with your Oceanbird wings?
I mean, the interest is very high, and I think this comes from you have new legislation coming in, CII, that means that you need to reduce the CO2 emissions on your ship. You can do that basically with different things. You can reduce the speed quite dramatically. You can put in new types of fuel. Or you can use the wind. So I think normally we say that marine industry is a quite conservative market when coming to introducing new technology. But here you don't have a choice. You need to do something, which I think creates a huge interest for everyone. They want to know. And also coming in with the future fuel prices with this also create interest. So right now you're coming in with new legislation. You have oil price that goes very high, and you don't know the new types of fuel. Where will the price be on that 15-20 years? Because when you build these ships, it's something that you have to live with for a very long time. And wind, I mean, it's a free energy source, so that makes it extremely interesting for many owners.
Yeah, and I mean, I know that the shipping industry has been trying new technologies for many years, and I had a friend of mine at here in the Evolution show back in December, and he's from California. His name is Ron Swenson, and he actually holds the world record for the world's largest kite to propel any kind of the vehicle on the ship vessel, 420 square meter traction kite, and he talked about saving 10% or more just using that in the front of a container ship or something. So this technology is not fiction. It's something that works, obviously, and we know historically that sailing ship has been key for shipping industry. But how much fuel do you estimate you could save using adding or rebuilding a ship with, say, 2 Oceanbird wings? Have you looked into these calculations?
Yeah, I mean, we do a lot of this simulation. And then, of course, the boring answer is that it depends. It depends on the route of the ship and so on. So if you are in an area with a lot of wind, if you go over the North Atlantic, of course, you will save more. If you're close to the equator a lot, then normally you have less wind. And also in the market, a lot of people talk about how many percent can you save and so on. We come into this with the 90%. For us, when it comes to the wing sail, it's quite static depending on, because you will have the same type of savings no matter where you put them on. So it very much depends on what kind of vessel you have. So what we look into is that you have approximately, on a normal route, which is not just favorable for the wind, you would save around 400 tons per fuel per year for each wing you have. Then of course if you put on 2 or 3 or 4, you will have more savings. So that's the way it is. Then if you take the North Atlantic, you will save a lot more.
Yeah, and if we talk about routing, since you mentioned it also, do you expect the Oceanbird wing sails to be used on specific routes, and how much does that play into, the fuel savings?
Routing is two things. I mean, one is of course, where do the ship operate? You don't want to go around Africa just because it's good wind there. So of course you need to look what is the sailing vessel's route original, and where does it end up. Then of course you have also the possibility to maneuver the ship in using the optimum in the wind. So normal vessel today, you go from point A to B, the shortest distance. Are you willing to do some small adjustments to that? You will get more savings for it. So that's regarding how much you can save for the routing.
Yeah, and if you look at 2026, when you plan or hope to have this vessel ready for the market, which is very soon, I think, for such a big vessel and very transformative technology, very exciting. And but if you talk about the routing, do you think the first ships and so on, do you have any idea where they should be introduced, or preferably perhaps to start with, in terms of saving energy?
These car carriers normally go around the world, so they spend quite a lot of time both on the Pacific and on Atlantic, which is very, very good for the wind. Then of course in longer term you can look into logistic thinking of using just these wind ships on the Atlantic, and then take it with other ships on other parts and so on. But right now, I mean, that's, as far as I've understood, is the plan to use it on the traditional routes.
Great. So that's really great. But okay, let's talk about the technology. I'm sure many people watching this wonder, this can't work, and this looks really, advanced and so on. But so let's talk about the Oceanbird wing sails and the wing rigs. Can you tell us how they follow the wind and how they fold?
Yeah, I mean, for you have seen before, I mean, the Oceanbird concept, it was telescopic wings that were going down, and then they were folded on the side. Now we've done a new design. So this means that we can reduce the size, but we can still have the same performance. So we actually half the size, but we still have the same performance. But that means also that we don't do them telescopic anymore. So we fold them completely on the deck. So it's a quite massive part that you're still going to fold down. It's 40 meter high, as you said, 15 meter or 14 meter in width, that you then fold down on the deck. Yeah,
and could you explain the design and the idea behind this sail technology?
I mean, it is very much inspired by the airplane wing. So it is basically an airplane wing that you put on top of a ship. So it consists of a mainsail and then a flap, and then you create the camber. And what happened then is that you will have the wind speed going faster on the backside, creating a pressure and moving, then you get the thrust. So what you want to create is as much lift. If you're thinking of an airplane, you have always a lift and a drag. So you want to create as much lift as possible and as little drag as possible for those designs. And there are of course quite a lot of studies done on how the optimum wings look like in this way.
Yeah, and actually one of my biggest inspirations are Leonardo da Vinci, and I know that he in turn had learned about, I don't remember, Borelli or something, the man behind the equation and technology for the lift technology, which he of course used in his inventions. So yeah, but the Oceanbird wings, they're 40 meters high and 50 meters wide. And how much of this height and weight is for balancing this 200 meter and 40 meter wide Oceanbird, and how much is to optimize catching the wind?
I mean, everything there is to optimize to catching the wind. I mean, we want to create as much as possible for that. Then, of course, it's very important when you go in and look to every ship. If you talk about retrofit on existing vessel, we need to go through then what is the stability, how many wings can you then put up so you don't have stability issues or these kind of things. So it's customized and adapt to each and every ship, and it also means that you need to do reinforcement sometimes on the ship, and so it's very difficult to say in general terms. I mean, we really go in for each and every type of ship.
Yeah, I understand. Okay, but one of the biggest benefits of propelling a freight ship with the wind is the significant decrease of underwater sound and pollution, which is of course a huge benefit for the oceanic life. Today we are decreasing the possibility for whales, for example, to navigate and so on. And you know obviously about this, and so I think it's fantastic that we go sort of back to wind, but still with the modern technology, new technology. So a combination of new and old, I would say. Can you tell us how the Oceanbird wing sails will affect the oceanic life compared to today's ships?
I mean, the effect is very big. I mean, you have today, you mentioned underwater noise as one part. You also have with the fossil fuel a lot of NOx, SOx emissions, CO2, not to say at least. And of course, with using the wind, we are then 100% free of those things. So that has a huge impact on the marine environment for sure. Really
interesting. Okay, but the Oceanbird sail, it's being developed here in Sweden, but where will it be manufactured? I guess it's Sweden as well. Can you say anything about that?
No, but since it's quite a big piece when you do this, I mean, we have developed everything in Tumba, and then we are using different partners in suppliers in Europe. So we don't see that we will manufacture it in one place and then ship it, because it's heavy and very big things. So we have it in different sectors, and then we assemble it when we put it on board the ship.
Yeah, and as you mentioned before, your main focus is the technology around the wing sails. So obviously you can get help from the shipbuilders and shipyards from other places as well. So
yeah, and all the wing sails consist of, I mean, you have a foundation that is quite heavy in this because you need to be able to take all the loads. You also have the fiberglass of the sails, because it's hard sails that we talk about here. So, and they're quite difficult to transport if you have them 40 meter and 15 meter in width. So in order to really change the world and make it possible and accessible for the entire fleet, then we see that this is the way we need to do it. Otherwise you will have special transportation, as you see with windmills, and you have to cut down trees in order to transport it from the factory and so on. So this has been a part of our development now, to see how we can also make it an industrial product.
I know that this Oceanbird project, from the beginning at least, was a collaboration also with the Royal Institute of Technology in Stockholm. Is this still the case? And because I will ask you soon about something related to that.
Yeah, no, yeah, it is for sure. I mean, the research program, as you referred to, that was a cooperation between SSPA in Gothenburg and KTH in Stockholm. And we kept them very close. I mean, they have a lot of competence and knowledge. So we work very, very close with both of them continuously. So the same people are, and also some of the people who were involved in that are now employed by Oceanbird. So we really kept it to make sure that we keep all the knowledge and in the company and together with them.
Yeah. And we're going to continue to talk more about this in part 2, but I would like to ask you, I got really inspired and hopeful by learning from the Oceanbird project. I've been following you for a couple of years, but I'm sure many others that are watching this, they want to learn more perhaps, or perhaps even want to take part in this project. So that's why I asked about students and research and so on. Is it possible to get involved in the project or other ways to support this project?
Yeah, I mean, we've taken quite a lot of people in from KTH. I mean, people who have done thesis on this Orcell and Oceanbird, and we are looking into hiring more people also coming. So we are building up the organization. So that's for sure a big opportunity in that. And we really would like to attract the people who believes in this and want to be part of changing the world. That's why we are really focusing on employing the best. So I'm really proud. I mean, we have one of the best team in the world on this. So if we can't do it, no one can do it. I'm convinced of that. And of course, you can always follow us on our homepage. We have the oceanbird.com. There we also put up all the positions that we have available. We are on LinkedIn, Instagram, YouTube. So there are a lot of places, and they can always contact us directly.
Yeah. Super exciting. And in the part 2, we'll talk more about, in broader terms, how we can change the oceanic shipping industry using your technology and other technologies. But thank you so much, Niclas. It was really great hearing what you're up to right now. And look forward to see what's going to happen.
Thank you. Yeah.
I hope you were just as inspired as I am about the Oceanbird project and shipping using wing sails. Next week, I'll be back with part 2 of my conversation with Niclas Dahl. This time, we look into the future of the oceanic shipping for sailing technologies, but also how it can be combined with other technologies and what we need to accelerate the change to fossil-free shipping on the sea. And I'm curious, what do you think? What challenges and opportunities do you see with the wing sail technology? And are there other alternatives you find interesting? Tell me in the comments below and I will look into it. And perhaps I can invite somebody working with the technology. Before you go, we really appreciate a thumbs up and consider subscribing. I hope to see you next week.